In 1987, a massive supernova erupted in the Large Magellanic Cloud. Now it seems to have left behind a neutron star. It's another Talkin' Science Story of the Week. I'm Matt Miller, you're on Trekzone, and we are 16 days into our August campaign for 2020. Can you help us help Guide Dogs Australia? We need you to beam over to bit.ly/TZ Guide Dogs and donate to our pack now.
With the latest science and space news 5 days a week across Apple Podcasts, Spotify, Google Podcasts and YouTube. This is Talkin' Science with Dr. Brad Tucker and Matt Miller.
And Brad, next up for our stories of the week, and it's a hot blob, moreover known as Supernova 1987A. So I was just under 1 year old when this thing happened in the Large Magellanic Cloud, and now it seems that a neutron star has formed.
1987A has been, one of the most studied supernova, and this is the thing, my actually main area of research, because it occurred in the Large Magellanic Cloud, so our neighboring galaxies on a dark night here in the southern skies. If you look towards the south, you'll see these two faint fuzzy clouds, and one's called the Large Magellanic Cloud and one the Small Magellanic Cloud. When a supernova went off on February 24th, 1987, it was super bright. It actually sent neutrinos here on Earth, high energy particles. We detected exactly 24. It was so bright that some of the bigger telescopes had a hard time almost staring at it because of how bright it was, because it was this nearby thing. It was visible in smaller telescopes and even to the naked eye if you knew how to look for it. So 1987A has been, a very well-studied object by being close. It's also a bit weird. It was a bit of a weird explosion compared to the ones that we have. And one of the big questions has always been, in big stars when they explode, which this was, do they leave behind a neutron star or a black hole? We think one of those two is left behind. And how do we find it out and how do we understand? And again, the more we study the things that are easier, so to speak, closer, bigger, brighter, however you want to call it, the more information we can gain that helps us into the whole understanding of those objects. And so now 87A, it appears that it did in fact leave a neutron star behind in its explosion.
And 1987A, it was the closest observed supernova to Earth since the invention of the telescope. So really makes sense that it's the most studied object. It happened at the right time for us.
I mean, that's right. And it still is. The only closer things we've gotten are in our Milky Way. And the last one of that was in 1604. So we've been waiting a while for this. We've been very patient. So it was exciting that it went off in there. And so, of course, things, all sorts of different telescopes, including the Hubble Space Telescope, which has been used to kind of pinpoint this neutron star, has been used in the follow-up. The Hubble Space Telescope has looked at this object one or two times every year since its explosion. We've seen how the remnant or the rest of the explosion, what we call the ejecting shell, and in this case it formed a ring, two rings in fact, has been leaving the center or the location of Supernova 1987A. We've seen how it's expanded. We've seen all sorts of things. And because supernovae are really bright, you have to wait a while for kind of all of the stuff to finish over, right? It's a huge explosion, so it takes a while to get through it. It also takes a while to actually move away from the exact location. And if you want to see what's left over at the location, you sometimes have to wait a while, in this case, a couple decades. And by now having enough clear area around the center of where 1987A occurred, and so therefore where the star actually was located, they were able to pinpoint that it does appear to be that a neutron star is now at that location where the supernova occurred.
Now, the blob itself isn't the neutron star, because neutron stars compress to about 1.4 times the mass of our sun into a sphere. So it's somewhere in there, and more than likely the blob is a giant gas cloud outshining everything around it, and the neutron star is sort of in there somewhere.
Yeah, neutron stars are about the size of a city. They're literally taking a star about our size of our sun, a bit bigger, a bit smaller, squeezing it into something that's only 20 kilometers wide, the size of a city. So these are really dense, really powerful objects. And generally, we've only discovered neutron stars through their radio emission. They sometimes, when we call them pulsars, they spin around super fast on the scale of milliseconds and are beaming out radio light. And so that's kind of how we found neutron stars in the past. So we kind of have to use what's left over. We have to use how the explosions moved, kind of taking a tally of all the energy, right? We've looked at different colors of light, different wavelengths. We can add up what energy is there. We can add up how the explosions happen and detect and calculate that something, as you said, the blob in the center is related to the neutron star, because we're never going to directly see that.
And the question of whether it is a pulsar or just a normal neutron star is something that is the next step in studying this object.
Yeah, because this is another great question. We think neutron stars are created from the explosions of massive stars. So when in their life they turn into a pulsar, these things, and pulsars are actually quite practical in terms of science things, and they spin so fast, so accurately, they're actually used as a way to independently calibrate GPS clocks. So, that's how fast they're spinning, but that's also how important they are. So this gives us another tool in science to use. So when we can look and monitor the birth of a neutron star, which ultimately this is, seeing how that evolves as well, and see when does it kick onto a neutron star, gives us a whole nother realm of understanding a whole different set of objects in the universe.
Well, Brad, on the next Talkin' Science Story of the Week, we're going to be chatting about Starships' successful first flight. I'm looking forward to this one. Very cool, backing up their Demo 2 success.
Exactly. Another tip of the hat to SpaceX and their successes.